We continue our discussion of lines, and here we're going to talk about linear functions and some of the most common types of linear functions. First, we say that a function f is a linear function if it can be written as f of x equals m times x plus b, where m and b are constants. Notice that there are no more restrictions here. M could equal 0. In the case where m equals 0, that means that we have a line with 0 slope. That means we have a horizontal line, which is known as a constant function. We could write the equation of the constant function as f of x is equal to b. If the slope is equal to 1, but the y-intercept b is equal to 0, then we have what's called the identity function, which can be written as f of x is equal to x. Notice that the graph of the identity function is a line that has a slope equal to positive 1 and that passes through the origin, which is also the y-intercept. Look at the four graphs below. In the first, we have a linear function that has a y-intercept equal to positive 2. And a quick calculation will show us that the slope is equal to, 2 divided by 10, so 1/5. And you'll see here in the equation below that that is what we have. So we have the slope is 5 and the y-intercept is 2. In the identity function, we have y is equal to x. That's the equation. So note that the slope is equal to 1 and the y-intercept is equal to 0. That's why it passes through the origin. In the third example, we have a constant function, which is a horizontal line. Let me go ahead and make that connection here. The constant function would have an equation that looks like y equals b, where b is the y-intercept. In this case, the y-intercept is at -2, and that becomes the equation of the line. Note that vertical lines do not meet the criteria to be considered a function, because to be a function, we cannot have ordered pairs with the same x-coordinate but different y-coordinates, which clearly we see as a violation in a vertical line. So a vertical line has an equation that looks like x equals a, where a is a constant. However, there's no mention of y here. This is all in terms of x. Next, let's look at how to write the equation of a line if we know its slope and we know its y-intercept. In this next example, we have a line with a slope equal to positive 6, and the y-intercept is the ordered pair 0, 8. Note that a y-intercept is always going to have the form 0, b. All right, so the slope is equal to 6. That is the coefficient of our x term. And the y-intercept has a y-coordinate equal to 8. So our equation becomes y equals 6 times x plus 8. In our next example, we have a line with a slope equal to -5/3, and the y-intercept is the ordered pair 0, 5, which again is the ordered pair 0, b. So here we have y equals -5/3 as the coefficient of x, and then we have plus 5, which is our b. This is the most common form for the equation of a line. This is called the slope-intercept form. Let's go ahead and add that to our notes here. So the slope-intercept form is y equals m times x plus b. There is another form for the equation of a line called the point-slope form. To use the point-slope form, we need to know two things about the line. We need to know its slope, and we need to know the coordinates of at least one point on the line. That known point is going to have coordinates x sub 1 and y sub 1. Even though we don't have a second point to have to worry about, the x and the y variables are going to appear in the equation, and so we want to differentiate between what are variables and what are fixed quantities. So x sub 1 and y sub 1 are going to be known values. X and y without the subscripts are going to be variables that can take on multiple values. The point-slope form for the equation of a line is y minus y sub 1 equals m times the quantity x minus x sub 1. Notice here that everything that is in a color is going to be a known fixed value. So y sub 1 is a known fixed number, m is a known fixed number, and x sub 1 is a known fixed number. On the other hand, x and y are variables for which we will not substitute values. Let's take a look at a couple of examples. If we have a line that has a slope equal to 5 over 2, and we know it passes through the point -3, 5, then we have the 3 fixed numbers that are needed to use the point-slope form. For example, the 5 over 2 is equal to m, our slope. -3 is x sub 1. +5 is y sub 1. So if we write out the point-slope form without substituting the known quantities, we have y minus, well, y sub 1 is 5, m is 5 halves, and then we have multiplied by x minus x sub 1, so that's a -3. Let's clean this up a bit and then we'll simplify. So we have y minus 5, equals 5 halves times x plus 3. And if we look at the instructions, we're told to write the equation in slope-intercept form. So we're going to rewrite the equation in the form here above. To do that, we have to isolate the y variable. All right, so anytime we're asked to write the equation in slope-intercept form, we just have to try to get the y variable on its own on one side of the equation. So let's go ahead and distribute the 5 halves on the right-hand side. So we have y minus 5 is equal to 5 halves times x plus 5 halves times 3 is 15 halves. Next, let's add 5 to both sides. So we have y equals 5 halves times x plus 15 halves plus 5. We're going to rewrite the 5 as a fraction so that we can combine those last two terms. 5 as a fraction with a denominator of 2 is the same thing as 10 halves. So notice that 5 and 10 over 2 are the same number. Lastly, we'll have y equals 5 halves times x plus 25 halves. Let's repeat this process for the next example. We have a line with a slope equal to -2 over 5, and we know it passes through the point 4, 5. Using the point-slope form, let's go ahead and write this as y minus 5 equals -2/5 times x minus 4. If it helps to label m, x1, and y1 as we did in the previous example, of course, please do that. Let's distribute the -2/5 on the right. And let's add 5 to both sides. We're going to rewrite that 5 as 25/5. So finally, we have y equals -2/5 times x plus 33 fifths. Now in the next example, we have similar instructions. However, we're asked to find the equation of a line that passes through the points 2, 3 and 1, -4. What's different about this example is that we don't have the slope already calculated. However, we can calculate the slope using the slope formula because we do know 2 of the points on the line. Once we find the slope, we can then use either of the 2 points as the point to substitute into our point-slope form. They both will give us the same equation in the end. So the first thing we're going to do is we're going to find the slope by using these 2 ordered pairs and the slope formula. So I found that, let's get rid of that negative sign. +7 is the slope. Now let's use either point in the point slope form. Let's just go ahead and grab the first point, 2 and 3, as being our x1 and y1. So we have y minus 3 is equal to 7 times x minus 2. Let's clean up the right-hand side by distributing. And let's add 3 to both sides. So we get that y is equal to 7x minus 11. I just want to show you here off to the side that if we were to have used the second point instead of the first, we still would have gotten the same equation in the end. So using the point slope form, let's use y minus a -4 equals 7 times x minus 1. So this becomes y plus 4 is equal to 7x minus 7. And if we subtract 4 from both sides, we get exactly the same equation. Next, let's practice graphing a line if we know its slope and if we know one point on the line. Let me make this a tad larger so that we could see what's going on. So we know this line passes through the ordered pair 4, -2. Let's go ahead and graph that point. 4 to the right of the origin and then 2 down. Because we know the slope is -1/2, we can use this to navigate to another point on the line. Now this is a point that I want to make clearly because there's always been a lot of confusion from students about what do I do with that negative sign. -1/2 can be thought of as -1 over +2, or it can be thought of as +1 over -2. All 3 of these are equivalent. So which one should we use to find a second point? Either interpretation will work. If we interpret it as -1 over +2, from this point we would go down 1 and then right 2. That would land us right there. Whereas if we use the second interpretation of +1 divided by -2, from the original point, we would have gone 1 up and 2 to the left, which would have landed us right here. Regardless, we found a point that falls on the line. Let's go ahead and, that did not work. Let's try that again. I was trying to make it nice and pretty, but I may have to just do this by hand. And it's not going to cooperate, is it? All right, let's see. Would have liked to do this a little bit more precisely, but I can draw this by hand. So if you have the slope and you know one of the points on the line, you can graph the line by first plotting the known point and then using the slope to navigate to a second point on the line. In the event of a negative slope, you have the option as to where to apply the negative sign, knowing that eventually you're going to find a point on the line. Let's take a look at a third way for writing the equation of a line known as standard form. So we've already seen slope-intercept form, and we've seen point-slope form. Now we have standard form. Standard form has the x and the y terms together on one side and a constant term alone on the other. I want to make a note here that all of these different forms represent the same line as long as we include information that is particular to that line. So any given line can be written in any of these three forms. In this case, we have x and y together on one side, which makes it easier for us to compute the x and the y intercepts. So let's review what the intercepts are. An x-intercept is the point at which the graph crosses the x-axis. Its ordered pair will have some number a as the x-coordinate and always 0 for the y-coordinate. To find the value of a, we simply let y equal 0 in the equation and solve for x. The y-intercept, on the other hand, is the point at which the graph crosses the y-axis, and to find the y-intercept, we would set x equal to 0 and solve for y in the original equation. Its ordered pair is always 0 for x and some number b for y. So let's use the following example to practice finding the x and the y-intercepts of a line. The equation of the line is 2x plus 3y equals 18. First, let's find the x-intercept. So to find the x-intercept, we're going to let y equal 0. So in the original equation, we have 2x plus 3 times 0 equals 18. Notice that 3 times 0 is just 0. So we simply get 2x equals 18, or x equals 9. That means that the x-intercept is the ordered pair 9, 0. Notice that x is equal to 9 per our calculation, and 0 is what we chose as the value for y up above. To find the y-intercept, we're going to let x equal 0. So we have 2 times 0 plus 3 times y equals 18. 2 times 0 is, of course, 0, so we have 0 plus 3y equals 18, or 3y equals 18, which gives us that y is 6. That means that the y-intercept is the point 0, 6. 6 is what we got for y per our calculation, and 0 is what we chose as the value of x. Now, if we plot these 2 points, 9, 0, and 0, 6, we have found the x and the y coordinates for the x-intercept and for the y-intercept, which means that we now have enough information to graph our line. Finally, let's quickly look at horizontal and vertical lines, which we mentioned in our previous video. Horizontal lines are these flat lines that run left and right but have no incline. They have 0 slope. The equation of a horizontal line is always y equals some fixed number b. Vertical lines, on the other hand, run straight up and down, and they don't have any horizontal movement. Vertical lines always have equations that look like x equals some fixed number a. Here we're asked to write the equations of the horizontal line and the vertical line that passes through the point 5, -3. So for the horizontal line, we know that its equation has the following form, y equals b. Well, in this case, what must y equal? Y must equal -3. That is the equation of the horizontal line that passes through that point. The vertical line, on the other hand, must have an equation that looks like x equals some fixed number a. What must a equal? It's got to be 5. So x equals 5 is the equation of the vertical line that passes through that point.